Welcome to the first of many Hewitt-Druitt screencast lessons in physics. I'd like to tell you how my love affair with physics began after I gave up boxing and at the age of 25 began painting signs in Miami, Florida. Newly employed, I was assigned to paint with a painter who was unpopular with the other painters. His name was Burl Gray, who it turned out altered the course of my life. I remember one day when Burl was on one side of our scaffold and I was on the other side, he started twanging one of his supporting ropes. I show just one strand of rope here for simplicity. He said, "Hewitt, twang your rope." His rope went boing, and mine went boing. He said the ropes behaved like guitar strings, and the fact that his twanged at a higher pitch was evidence that the tension in his rope was greater than the tension in my rope. That made sense because Burl was somewhat heavier than me. Tension is the force within a stretched rope. Somewhat later, I'm walking over toward Burl to borrow one of his paintbrushes, and Burl says, "Aha, as you walk closer to me, will the tension in my rope increase?" And we both agreed that it would because his rope would be supporting more of our weights. Then he asked, "As the tension in my rope increases, will the tension in your rope decrease?" It seemed reasonable that it would, but Burl went further and asked if the tension in his rope increased by 50 pounds, would the tension in my rope decrease by 50 pounds? Or, going further, if his rope increased by 50.1 pounds, would my rope decrease by 50.1 pounds? Exactly. If so, wouldn't that be wild? For how would my rope know what's happening in his rope? How would the ropes know? Neither of us had an answer to his question nor a good explanation. Neither of us had any background at all in physics. Sometimes not too quickly having answers is a good thing. Wondering can be wonderful. Discussions of this sort, and those with Burl's friend Jacques Fresco, are what prompted me to leave the sign painting profession and make a giant leap to furthering my education and learning science. Months later in prep school, preparing for college physics, I learned the equilibrium rule and shared my knowledge with Burl. The equilibrium rule states that the sum of all forces that act on a system will balance to zero if that system doesn't change its state of motion, if it's steady, for example. Burl, I, and the scaffold were part of a system, one that nicely stayed in equilibrium. The sigma sign stands for sum of. More correctly, the vector sum of all forces will equal zero for a system in mechanical equilibrium. Yum. I contacted Burl and explained the value of identifying the forces involved with our scaffold. There were 3 downward forces due to gravity. Burl's weight, the weight of the scaffold that could be considered at the center, more about center of gravity later, and my weight. If these were the only forces in the system, we'd be in free fall. But the ropes provided upward forces, tension in Burl's rope and tension in my rope. What's the sum of these forces? The equilibrium rule says that the downward forces are matched by upward forces. That the upward tension in Burl's rope plus the upward tension in my rope minus Burl's weight minus the weight of the scaffold minus my weight equals 0. Knowing that rule bypasses questions like how does one rope know how to gain and how does the other rope know how to lose? How much richer it is to know that the ropes, scaffold, and us comprise one system. And if that system's in equilibrium, then all the forces acting on it will balance out to 0. I later learned that the equilibrium rule is related to Newton's laws of motion. Learning these laws was learning the rules of nature, wonderful rules that make sense of the world. I want to leave you with a question. If Burl and I both stood at the far end of the scaffold and leaned outward a bit, so the opposite rope went limp. What would be the tension in our supporting rope? Think about that. Until next time, good energy. I sign off with a short poem that I use to sign all my art. Hewitt drew it. Yum. Next time.